Mean, median, mode, and range are all math concepts that you should be very familiar with by this point. However, in 7th grade, we take it a step further and see how things like outliers affect the data description, such as mean, median, and mode, or which one is the best description of the data. Let's start by defining each of these in case you get them a little bit mixed up. Mean is where you add the data values together. So it's the sum of the data values divided by the number of data values. The median, it's the middle value, but that's only when the data is arranged in order from least to greatest. It's not the middle of how the data is presented. You have to order them from least to greatest and then find the middle. If there happens to be two numbers in the middle, then you average those two. You take the mean of the two middle numbers. The mode is the data value or values that occur most often. So there could be more than one mode if there was, two different numbers that were repeated 3 times, and they would both be the mode. If there are no repeats, then there is no mode. And then finally, range is the difference between the greatest and the least value. You'll hear these called measures of central tendency, but that does not include the range. Mean, median, mode are your measures of central tendency. Excuse that. So with them being measures of central tendency, they describe the data on average, you'll hear it say. So when you say on average, it doesn't always mean find the mean of it. What is the best description of the data? And so usually mathematicians they'll use the mean, median, or the mode to describe the data. Range falls in a different category. It is a measure of variability.
Any student that has not had their pictures made but wants them made needs to report to the stage area at this time. This is last call.
Other measures of variability would be things like interquartile range or mean absolute deviation that we'll look at later in the unit. So let's practice finding the mean, median, mode, and range of a data set. So for the mean, we're going to add those up. 2 plus 1 plus 8 plus 0 plus 2 plus 4 plus 3 plus 4, 2, 1, 8, 2, 4, 3, 4. When you add those up, you get 24. And you're going to divide that by 1, 2, 3, 4, 5, 6, 7, 8. So the mean is 3. For the median, we have to put these in order from least to greatest. So I'm going to do that. This is where it's in your interest to rewrite the original data set if you don't have a piece of paper with it already in front of you. That way, as you're putting them in order, you can mark them off. Like I know 0 and 1 are going to be the first ones. Then I have 2 2s. I have 1 3. I have 2 4s. And then I have 8. So I can recount my numbers to make sure I didn't skip one or duplicate one. 1, 2, 3, 4, 5, 6, 7, 8. Now that I have them in order from least to greatest, I'm going to find the middle. And also a benefit of having them written is you can use your fingers and work toward the middle. So the middle is falling in between the 2 and the 3. So if you were to average those together, 2 plus 3 is 5 divided by 2. So the median is 2.5. For the mode, I can look at where I've already listed them and see my duplicates.
The book group to report to the library. Book group to the library.
I can see the duplicates of 2 and 4. So I have a mode of 2 and 4. And for the range, the difference between the least and the greatest, 8 minus 0 is 8. So there I have my mean, median, mode, and range. Something else I want you to think about, though, is an outlier. So here's the definition of an outlier. It is a value that is much greater or lower than the data. So we're going to analyze what would happen if 30 was added to the data set. So I'm going to do that in blue to show if the outlier was in there. So if I were to add 30 to this data set, that means my sum would increase to 54, and it's now out of 9 values. So the mean then would be 6. If I were to add 30 on the end there to find the median, my middle now is 3. So my median is 3. My mode, it doesn't change. The range does change, and the range would then be, not minus 2, minus 0. The range would then be 30. So let's make some observations here. When you have an outlier, it does affect the mean. Our mean doubled. It doesn't seem like there's a big difference between 3 and 6, but if you were to say, on average, let's say this was ages.
Abby McKenty and Isaac Steele to check out.
Let's say
McKenty and Isaac Steele.
that this data represented the ages of people at a birthday party or something. I have this 130-year on the. You see how that's not right? Like, it's kind of weird. And I would say on average, people are 6 years old, when in reality, only 2 people are 6 years or older. Most of the people are very young. Or if I was looking at a nursery, the ages of people in a church nursery, this person's the teacher. So I wouldn't say on average that people in that room were 6 years old. Now the median barely changed. So an outlier has very little effect on the median. The mode didn't change at all. And so in most cases, the mode is not going to change with an outlier unless I had 2 30s up there. Then I would have 30 as a mode. The range does change, but that's showing that you have a big variability. I have a difference of 30 years in that room. So with that last board, we saw how an outlier affects measures of central tendency. Now let's see how to choose the best measure to describe a data set. So here's a good table for you. These measures of central tendency are most useful when, and these are the situations where they would be most useful. The mean is the most accurate and most useful when the data is spread evenly, meaning that there aren't many outliers, or not really any outliers at all. The median is best used when the data has an outlier, like in our last situation. Or if you hear government statistics of what the average household income is in America, you have most people, are middle class, and then you have a few that are crazy wealthy. Your athletes that are making $12 million a year. That is very different from a teacher making $35,000 a year. So a lot of times you'll hear those statistics of the median household income because those outliers really skew the data. Then you have the mode. It is most useful when you have data that involves a subject where many data points of one value are important. If I were talking about the age of students in my classroom, I'm going to have lots of 13-year-olds. So I might use the mode to describe the age of kids in my classroom. Okay, on the practice, I'm going to go through and explain what I mean by these because it's a little different from a lot of the practices you've done in previous videos. First, you're going to find the mean, median, mode, and range of the data set. Pretty, self-explanatory. Then you are going to identify the outlier, and then how does the outlier affect each of those things? So go ahead and pause the video, try to work this out, try to answer these. You'll notice that especially on number 3, it's not a number answer, there's some explanation in there, and then see how that compares with what I come up with. for number 1, the mean, when you add those data pieces together, you get 747. There are 10 data pieces, so that is 74.7. When you looked at these numbers, you may have thought, those sound like some of my grades that I might get on quizzes, and that very well could be a set of quizzes. And that 0 could be the one that you completely bombed or you just didn't do, and so you got a 0 for it. The median is one of the higher ones. So the median ends up being 86. The middle falls between 84 and 88 when you put them in order. You average those two, you take the mean of the two middle values, and you get 86. The mode is 88. That's the one that's repeated. The range is 93 because you're going from 0 to 93. You may be thinking, well, aren't my grades in the grade book figured on a mean? Yes, they are. So for some of you, the median might be a better description. That's when we try to push you to not have any zeros in there, because we know how that really drops your average. And some of you know that all too well. And then number 3, how does the outlier affect the mean? It drops the data average. If I did not have that 0 in there, I would be taking 747 and dividing it by 9 instead, and you would have an 83 average. So if this were your actual class average, you would go from an 83B to a 75C. That's a big difference. The mean with the outlier is actually lower than most of the data values. A 74.7 would fit right here. So that would say, oh, on average, this kid is 75, roughly 75% accurate. When in reality, there was only 3 times that they were lower than that. The rest of the time, they typically did better than that 74.7. The median, it barely drops it. If the 0 was not there, the median would be an 88. It just barely drops it. And then the mode is not affected at all. The mode would still be 88.